Do you know how developers are able to collaborate when working in the same project? Keep track of their changes in their code without messing it up all. Let me introduce you to the solution that have saved developers a massive headache. But has it really? Well, this piece of marvel is the version control system. We'll learn by doing, of course, and some basic concepts. Stay here as you're about to level up. What's up, friendly coders? Today we're going to be talking about version control systems. We'll be covering topics like what is a version control system and why do you need it, different version control systems and version control system hosts. We'll also see an intro to Git and GitHub. Of course, we'll also see how to set up our own project with Git and GitHub, plus some of the most basic Git commands. This video is packed with a lot of valuable content, so make sure to watch till the end so you get those new skills sharp. Okay, as we are going to be talking about the version control systems, and this is a very long word, I'm just gonna use the initials VCS, so make sure to watch out for that. If you're working on a development project, for sure you will need to use a VCS, so you can keep track of all the changes on your project. But not only this, what will happen if your machine just breaks down and you don't have any copy of your source code? This is where the VCS hosts comes in as well. More on this next. Let's see first what is a VCS and why do you need it. So according to Atlassian, version control, also known as source control, is the practice of tracking and managing changes to software code. Version control systems are software tools that help software teams manage changes to source code over time. Okay, this is all great, but what are the benefits of using a VCS? Well, the benefits are a complete long-term history change for every file, meaning that if you modify any file or any piece of code, you'll be able to have access to this information in the future. Okay, so the next benefit is branching and merging. This refers to the fact of being able to branch off of a master branch, or let's say the original version of your code. And with this new branch, you will be able to change certain code, yet without affecting the original version of your code, and then only when you're happy with the changes, merge this to your master branch, or, as we said before, to the original version of your project. The next benefit is traceability. These other benefits refers to the idea of being able to find your code easier in history, as every time you make a change in a branch you are working on, a commit message is recorded so you can refer to it easily, as the message should describe the change you just have made. The truth is that all of these concepts are a bit confusing. I remember when I was first learning this, I found it a bit abstract. So I thought that with a simple example I could explain you so you can understand it easier. Okay, so I'm going to explain to you how version control systems actually work with very simple examples. In this case, I'm going to be starting with branching and merging. So here in this example, we have a master branch, which is this guy we have here. And we have a branch we have created out of this branch, which is our clone 1. And we also have our clone 2, which is our branch 2. So with each of these branches, we want to teach these characters how to jump, and in the other branch we want to teach this character how to swim. So think of it like you can create a clone of yourself, and this clone can learn something else whilst you are learning something else. So you don't have to wait so much time to learn one skill. So this is practically the same. You have created 2 branches, and each of these branches are going to learn something new. Okay, so once you have created the code for your branch, for example, in this case, we have code our branch 2, and now this little character knows how to swim. So what we want to do is to merge this branch back to our master branch, which is our original branch, or you can call it like our main branch. So once we have done that, we have transferred the skills that this little character has learned back to master. So now masters know how to swim. So you can think of it like a fusion. If you have ever watched Dragon Ball, you can see it as Goku and Vegeta's fusion, creating this more powerful being. Now the same applies to our branch 1 or clone 1. Let's say that we have developed our code and our little character already know how to jump.
So we can actually merge this character back to master. So now our master branch learn how to swim and how to jump. Merges are not always that easy, and in this case I'm going to be talking about merge conflicts. So let's go back to our example before, and let's say that we have a master branch and we have a clone of that master branch and another clone of that master branch. So with this clone or this branch, we want this little character to learn how to run. With this other branch, we want this character to learn how to walk. Now, let's say that we have developed the code for our clone 2 and our little character here already knows how to walk. That's great, that's perfect. What we can do is just merge it back to master, and now voila, master knows how to walk. But if you think about it, these two branches have something in common. Like, if you're going to develop the code for this branch, for it to learn how to run, you probably want him to learn how to walk as well, because normally you need to learn how to walk first for then you to learn how to run. So there's going to be some kind of conflict or clash here. So if we have developed our code on our clone 1, we said, okay, let's teach this guy how to walk first. So we have developed maybe a function or certain code that help him to learn how to walk. And then we have code something else or another function to teach this guy how to run. So now this guy knows how to walk and how to run. What will happen when we try to merge this back to master? Well, master is gonna be a bit confused. It's going to be like, okay, but you know what? I already know how to walk. Yeah, maybe I don't know how to run. I can accept that part of the code, but what do I do with the walk part? So what you can do with merge conflicts is to resolve them in a certain way. In this way, you could do, okay, so as master have learned how to walk from our clone 2, we can tell him, look, just keep the walk part of our clone 2 and let's keep just the run part of our clone 1 or branch 1 and let's merge it back to master. If you do this, you resolve all the conflicts and now master learn how to walk and how to run. Okay, so another benefit of version control systems is traceability. In this example, we have a master branch, we have our clone, which is just an extension of my master branch. And what we want to do in this case, like the end goal, is to learn how to swim. But to learn how to swim, we are going to work on stages, let's say. So the first thing we want to do is to learn how to float in the water. And then we can actually learn how to swim a certain style. So normally with branches, we work with commits. Think of this like a checkpoint in a game. Like normally when you are playing a game, and you have reached certain point, then the game is saved automatically, and if you die in your game, then you are coming back to this checkpoint. So commits are something very similar, and it allows you to keep track of your work, like the changes you have done in a certain commit, and then you can create different commits so you can know what piece of code each commit will have changed. Okay, so with traceability, you can keep track of your commits on your feature branch or your clone branch here, but you can also keep track of these changes once you have merged your feature branch into master. So what happens is that the commits that my clone 2 had will be now exposed by our master branch. So we can go to our master branch and refers to those commits where that change of code happened before. And this is very helpful because you can see in a certain point in time when something changed in your code base. Okay, so another benefit is long-term history, and this is very similar to traceability in a way that we can keep track of our commits. In this case, we have our master branch. We have created a branch, a new branch. Like in this case, this is like the 100th branch we have created, and with this branch we want to learn how to climb. So let's say we have created all our code there, we have developed what we needed, and we have merged this back to master. So now master will have all the old commits from other branch plus the commits of the new branch that you create and merge to master. So again, as in traceability, this is very helpful because you will be able to go back to your history on your master branch and see all your commits and see what have been changed in each of those commits and maybe revert it if that's what you want.
Okay, now that we have talked about the concepts of VCS, let's see which of the software tools can we actually use. Let's see what are some of the VCS available. Okay, so we have Git, Mercurial, SVN, and CVS. The most used ones are Git and Mercurial. In my experience, just by learning Git should be enough as it is the most widely used. As there are many VCS, there are many VCS hosts as well, or code repositories, and some of these are Git, Bitbucket, and GitLab. All of these repositories are famous and probably you'll be working with all of them. The most popular one in my opinion is GitHub, but still you will still using Bitbucket in big enterprises. I have worked with both professionally and probably you'll find them in your next job. Now let's go deeper with what Git and GitHub are. Git stands for Global Information Tracker, and according to Git is a free open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. Git is most known as a DVCS or distributed version control system, which means that you will have the entire history of your Git repository on your machine, and not only in the cloud where the VCS host lives. This is important to know because in the past you would normally work with VCS that wouldn't allow you to have the Git repository history in other places, just in one place. Okay, now let's talk about GitHub. According to Wikipedia, GitHub is a provider of internet hosting for software development and version control system using Git. It offers the distributed version control and source code management functionality of Git, plus its own features. So essentially, GitHub is a repository of code that has Git's functionality and can manage source code as you would do it normally on your machine with Git. But nowadays, GitHub is much more than that and can offer you many other features like website hosting with GitHub pages, code spaces, and many other features that we won't be covering here. Before we go any further, if you are enjoying this video and you want to support me and support this channel, make sure to subscribe, like, and leave me some comments there. Okay, friendly coders, this is the fun part where we are going to set up our own project with Git and GitHub. So let's go to our machines now.
Okay, friendly coders, let's go now to the fun part and install Git in our machines. We'll also create a GitHub account so we can store our repositories there. So we'll be creating a project locally and we will then push it to our repository in our GitHub account. And also we will clone another repository from another GitHub account to our machines to see how the process is. Okay, so let's start by installing Git in our machines. To do that, we will want to check first if we have Git installed in our machines. If we don't have it, then we can proceed and install it. So let's come here to the terminal and let's type git version, and this will display the version of Git we have installed once we have pressed the return key here. So as I have it installed, it will show me what version of Git I have installed. If you don't have it, probably it's not gonna show you anything here, or maybe it's gonna throw some kind of error, or it's going to ask you to install Git. So if it prompts you to install Git, go for it and install it from there. If not, let's do something else and let's actually search on Chrome or any other browser how to install Git. So one website I would recommend you is to go to Git SCM, which is the website of Git, and if you go to the section downloads, you will find how to install it on any of the operating systems that there are. So we have macOS, we have Windows, we have Linux. Just choose the one you are using on your current machine. In my case, it is Mac, so I'm gonna go for it. And here it is telling me, look, you can install Git with Brew. So you can do Brew install Git, or with these other options. I would advise you to do it with Brew. If you don't have Brew installed, you want to do that, and to do that you can just go to home view website. So just go to your browser, type view.sh, and you will find here how to install it. Basically it's just this command. You can just copy it here, come to your terminal, paste it, and run it. I'm not gonna do it because I already have Vue installed. So that's something you can do. Let's say that you already have Vue installed. What you want to do then is just to copy this. Let me just zoom in a bit. Copy this command and paste it here, and then run it. I'm not gonna do it because I already have Git, as you saw, but this is the way you can do it. Okay, so once you have installed Git in your machine, what you can do to check if it was installed successfully is to come back to your terminal and type git -- version, and this will print out the Git version you have installed just now in your machine. So if you have that, then you're good to go. What we want to do now is to create our GitHub account, where we will create our repositories and store all our code in there. So for that, let's actually go to Google Chrome or any other browser you're using, and let's search for GitHub. So we want to go to this one, and we want to sign up for a new account. Again, I'm not going to do it because I already have an account. So I would tell you just go and create your account, follow all the steps. Okay, so I'm just going to sign in here to my account, and once you are signed in, you will be presented with this dashboard. So here what we want to do is just to create our new repository where our code will be stored. So for it, let's just click on this button, create new repository, and let's actually add a name for that repository here. So here maybe I want to name my repository learn-git. Okay, now we can provide a description for the repository, but this is just a demo, so I'm not going to actually create a description here. I want my repository to be public. That means that I can share this repository with anyone, and anyone will be able to have access to this repository. Here we can add a README file just to describe what this project is about, but I'm not going to do it in this case. We can add a .git ignore file. I will talk about this later on. And ultimately what we want to do here is just to create our repository. So let's skip all those steps and let's create our repository. Okay, so once we have created our repository, what we want to do is to create some kind of code for us to store on this repository. So now the repository lives under your username account and / the name of your repository. So in this case, it is just /learn-git. You will be able to see it here as well. This is going to be the remote of your repository, but I'm going to explain that later as well. Okay, so let's create our own project. Let's come to our desktop and let's say we want to create a new project. So let's create a new folder and we're gonna name it learn-git as well. Learn-git. Okay, great. So once we have created our project, what we will want to do is to create some kind of code in it, and for that VS Code is my best option. So let's go for it and open this folder with VS Code. Okay, perfect. So here you will see the name of your project, and now actually create just a file. We will call it index.html. Okay. So once we have created our file, if we want to just create some kind of template, let's just press Shift and 1 or just type an exclamation mark there, and this is going to create this template out of the box for you. And this is just a HTML file with its head, its body, and that's it. Don't worry about this. This tutorial is just about Git and version control systems. Okay, perfect. So let's actually, I don't know, add something on this body. Let's create a h1 tag and let's put here a title, learning Git. Perfect. So once we are done there, let's save it. And now we have all of this code locally, but what we want to do is, again, just to push it to our repository remotely. So to do that, let's actually bring on the terminal here. Okay, so we have opened our integrated terminal on VS Code, and to initialize any project on Git, there's a basic command you should know, and this one is git init. So we can type here git init. Okay, so this have created a new Git project. Let me just clear this out. This have created a new Git project, and we can see that now probably your folder, just beside your folder, you have a name master here, and this is because when you create a Git project, it automatically assigns the name master to that branch. So what we have done is to create like a main branch, and this main branch is master. Okay, so now that we have this master branch, what we want to do is to save all the changes we have done in this project. So what are the changes in this case? Well, just this index.html file we see here. So to do that, we need a way to save it. So what command can we run? So for this, we can use the command git add and a dot. What this means is going to save all the changes in this directory that have been performed in this directory. So git add and a dot at the end. You need to leave that space there. So once we have done that, we'll see that it has a +1 here. So it means that, look, there have been some changes in my project and we have saved it. But in order to push these changes, we need to commit this change. It's like some kind of, let's secure it, let's make it live on this branch from now on. So to do this, what we want to do is just to add the command git commit -m. We open double quotes here, and we can add any message we want. In this case, we are learning Git, so let's actually commit it with learning Git. Here it can be any message that resembles what you are doing in your code, ideally. Okay, perfect. So we have committed the changes. Now, what we want to do now is to push these changes to our repository, and there's a command for that. So our command is git push. So if we enter git push, we'll see what will happen now. It will say, hey, look, there's no destination set up. So yes, it means that we have created this new repository, but our local environment doesn't know anything about it. So what we want to do is just to tell our branch where to store that new piece of code. So to do that, we'll need to go to our GitHub repo, the one we just created, and we'll see that here our repos tell us what's the origin, like what's the address where we want to push these changes. So in this case, this is the address. Well, this is the address, and this is the command you should run to add that address to your local version of your code. So simply what we can do is just to copy this and paste it there. So basically it's git remote add origin and the address, as it told us here, git remote add origin and the address. So here it is. If we do this, now we have that remote added to our branch. So now what we want to do is to push these changes to our repo. Okay, so before we push our changes to our repo, One thing I forgot to mention here, and is something that you might want to do, is to set your Git username and Git email with a few comments. So this is for you to kind of sign off your commits. So once you make some changes, then Git or GitHub will know who committed these changes, who pushed these changes before. So to do that, what we want to do is just to write the commands git config -- global user.name and then your username. So probably this is going to be your username on GitHub. Case is dev Esteban. In your case might be another one. I won't do it because I've done it before, but this is for you to know. This is something you will need to do just once, so probably you won't remember this all the time, so don't worry about it because it's just once. Another thing you want to do is after you finish setting up your name is to do git config -- global user.email. That's the next one, and you will add that email that is associated to your GitHub account. So I don't know, like dev@gmail.com, for example. Well, here is not Gmail but Gmail. There it is. So that's basically it. That's what you need to do in order to associate your Git account to your Git. Okay, perfect. Okay, so once you are done there, what you want to do is to push your changes. Okay, so to push our changes, what we want to do is just type git push, but let's see what will happen here. So once we have entered git push, it will tell us, oh look, something went wrong. So you were trying to push to your remote, but there's no master branch on your remote. So what you want to do is just to set this master branch on your remote. So for you to do this, you can just simply copy and paste this, or just type it git push -- set upstream origin master. So you will need to do this for every branch you create, but we will see that later on. Okay, so git push set upstream origin master. Okay, perfect. So we have pushed all the changes and we have set it the upstream. So if I make any other change now, I won't have to do this git push set upstream or whatever again, and we can just see it in a bit. I'm going to show you what happened now that the pushes have been through. So if we come back to our GitHub account or our repository and we refresh our browser, we'll see that we have our repository with some file there. And this is actually the file we have submitted, the file we have pushed. And there's a commit message here, which is learning Git. This is a commit message we added. So if we come to this file, we explore, it is actually what we have here. So if I just zoom in a bit, we'll see it says here learning Git, just as it is displayed here. So we have successfully sent our code to this repository in the cloud. So we can see here all the branches we have on this repository. So in this case, we have only master. We can create multiple branches, and this is something we're gonna see now. We can come back to our repository, and yeah, this is everything we have on our repository right now. We can see that it's devesteban/learn-git, and it's a public repository. Perfect. So let's actually make one simple change to this. Let's say that we want to remove that exclamation mark. We save the changes. So now if we do this git status command, with this git status command, we can check how our Git workflow is going. So we have pressed git status, we have run that command, and it says changes not staged for commit. There's one change not staged for commit, and this is the change. and the change is in this file, index.html. It is telling us, and we have an exclamation mark as well here, like, oh, something happened there. Okay, let's just git add this. This is like some kind of, let's save that change in this branch locally, and let's change it, let's completely save it with git commit. So let's use the same command, but let's put another message, and for this message is going to be removed the exclamation mark, for example. So let's actually hit enter, and the change has been true. So what we can do now is just to push these changes to our master branch. So if we do this git push, we'll see that it won't ask us to set up an upstream again because we have done it once. So let's see. If we do git push, perfect, it went through. So it's telling us all the changes that happen on the file and how heavy the file is now. But well, let's not focus on that right now. Now let's come back to our repo on GitHub, and we'll see that there's a new commit message after we refresh our repo, of course, our page. And if we go inside this index.html, we'll see that there's no exclamation mark there anymore, so the changes went through. Okay, now let's create another branch. And what is the purpose of creating another branch? Let's say that we want to work on this code, but we don't really want to change anything on this master branch. We want to have a copy saved somewhere of the code we have written without affecting it. So let's keep it like that. Let's keep master just with the code it has right now. For this, we want to create a new branch, or let's say a feature branch. To create a new branch, the command you have to run is git checkout -v and the name of the branch. Let's call it feature / dev Esteban. In this case, you can add maybe your name, dev Julia, dev John, or whatever you prefer. And once you have added that, let's hit enter, and our new branch has been created. So as we can see here, our branch now is feature dev Esteban. So it means that whenever we make changes in here, we are not going to affect the master branch. Okay, so let's see how this works. So if we come here, let's say that right now for this new branch, I want to create another tag, and I want to add like some kind of, or some sort of description, learning Git. Okay, so this is my first time learning Git. Okay, let's say that we have added those changes there. Let's save it, and here, as you already know, let's do git add, git commit. Let's add some other message like added description, for example. You can put anything you want there. Okay, let's see what will happen now. If we do a git push here, if we type git push and we hit enter, we'll get the same message as before. You need to set an upstream. So as I said before, you need to do this for any new branch you create. Okay, perfect. So this is very handy. We can just come here, copy, like Command C, and paste it, Command V, and let's push and set that upstream. Okay, perfect. All the changes have been pushed. Now let's see where do this branch live and what are the changes it has. Let's go back to our repo, and we'll see if we refresh our repo and we come to this master button, we click it, we'll have a new branch, and this is the new branch we have just created. So if we come to this branch, we'll see we have the new changes. This is my first time learning Git. So this is amazing because we haven't modified anything of what we have on the master branch. So if we come back to our master branch, look, the changes are intact. What I can do after is just to merge these changes from my Fisher Dev Esteban branch to our master branch, but I'm not going to explain that here. I'll probably create some sort of crash course later on, but this is for you to have an idea what will happen. Okay, now to finalize this tutorial, I want to explain to you how to clone projects or how to clone repos. This is a practice we all developers do all the time because there are different repos we'll need to copy from in our company for projects that we are working on ourselves and for many other reasons. But in this case, I'm going to give you the link of one of my repos and you will be able to clone it from your PC. So I will be leaving the links below in the description of the video so you can follow along with me here. So basically just go to the link, open it, and here once you are on my repository, what you can do is come to this code button, click it, and you'll see that here you can clone the repository. It says clone. You can clone it with different methods. It could be HTTPS, SSH, or the GitHub CLI. In this case, let's just stick to HTTPS, and here we can click this button just to copy our link to our repo. So once we have done that, what we want to do is come back to our terminal. Let's open a new terminal tab and let's actually do something. You will want to clone this project in the area that you want to store it in your machine. In my case, I want to store it on my desktop, so what I would want to do is just to move to my desktop directory on my terminal. So to do that, let's go to our terminal here. Let me just zoom in a bit and let's actually go and say, okay, cd desktop. Okay, now here we are on desktop. We can do ls just to check. So we have other tutorial learn Git, which is what I have here. So perfect. Okay, now let's do what we came to do, which is just to clone the repository. So let's do git clone and let's paste that link we previously copied and hit enter. Perfect. So once we have done that, we'll see that our project is here. So here it is. VCS tutorial. So if you have done that, congratulations, you have cloned your first repository and this is the first of many to come. You can verify this project by opening it with VS Code, so we can just drag this folder to our VS Code and see what is inside, and you'll find yourself with an index HTML saying hey dev, be awesome, and learn Git and GitHub, and a readme file. That's it. That's all you need to know to start with Git and GitHub.
If you have watched the video and gone through the whole tutorial, congratulations. I can assure you that this is one of the most useful things to know when collaborating with other developers and also creating your own projects like a pro. VCS is much more deeper than what I've covered here, but you can be safe to know that you can start working with this knowledge and the rest you will acquire it little by little, coding your own projects with your friends or colleagues. If you still want to learn more, check out my Intro to Web Development series. You can find the links here. And of course, if you have enjoyed this video and learned something new, make sure to subscribe, make sure to like this video and support the channel. See you in the next one. Bye bye.